Okay, let's do a quick recap on what we've learned so far. Alright, arithmetic progression. An example would be, say 10, 13, 16, 19, Correct? An example would be like that. Just add 3 and 3. Now, can anyone tell me, without referring to your notes, all look up. What's the formula for the nth term? A plus n minus 1 d. Where did you get this extra from? On Tuesday, I asked so many times. What do you mean somehow it appeared? I asked at least 3 times, right? What's your name? Huh? Jiaqing. I asked at least 3 times. I asked you to find. Now you tell me you return this to me. That means you didn't check carefully. You wasted everybody's time, you know. And now I have to bring one more copy for Jared. Now this copy how? You tell me? You pay. You keep some tree. Not one tree, but next round, no, I'm not bring one copy for you, I tell you. Seriously, I really reminded all you check, you know. Aiyo, my goodness. Jiaqing. Okay. Sn. Sum to n terms. Anyone can remember the formula? Without referring to notes, let's all look up. There's what? N plus un. A plus un times n over 2. This is the easier one. This is your last term, right? Correct? This is your last term. Alternatively, let's say you don't have your last term. Of course, you can calculate if you have A and B, but the other form is n over 2. Oh, sorry. Why am I doing that? 2. Some more? 2a plus n minus 1d. Of course, you can convert between these two quite easily. Correct? You just substitute this with n and this and the right? Yeah, so you do enough, you actually don't really, you remember this one quite comes very naturally. Okay? That's all we learned. We also learned how to prove that whether a sequence is an AP. Correct? If you want to prove a sequence is AP, you need to prove that un minus 1 is a constant. Actually, when I say it's a constant, of course, in the end, you prove that this minus is a constant for all values of n. We have proved that if it's equal to 4, fine, no problem. It's always difference 4. But if you prove that this one is equal to, say, k, is this still n? K, for some number k, that means you have something like that, you have a plus k, a plus 2k, right? A plus 3k. Of course, it should be, correct? Now what if you, in the end, you prove that un minus 1 is equals to n squared? Is it an AP? No. You follow what I'm saying? Why not? Because this, if it's n squared, it will be dependent on the value of n. You follow what I'm saying? So actually, when we say constant, we actually mean constant independent of n. Correct? That means it can be any constant like k, whatever. As long as it doesn't depend on n, I think we're good. It must be k. You follow what I'm saying? Okay? Alright, let's continue. Okay. We are at example 6. Okay, example 6. Example 6. Part B. Find the sum of the following A arithmetic series. You have this. Now, this, you can quite obviously see that this the common difference is 2. Sorry, minus 2. Negative 2 because it's a decreasing series. A sequence, sorry. Yep. And your first term is 3k plus 97. Again, we can easily find the number of terms using what? Using this idea. Un equals to A. You don't have to write this, but I'm just trying to say that this you are making use of this, right? Alright? Use of this. This is the nth term, first term, plus n minus 1, d. To make use of that. The only unknown is only n. So you have 49 terms in total. You have 49 terms in total to find the sum. Therefore, it should be, you quote the formula 49 over 2. First term, which is 3k plus 97. Last term is 3k plus 1. There you go, answer. Okay? All okay? Good. Then your final answer is in terms of k. Question. All good? Question 7. Example 7. I want to highlight this word using an algebraic approach. That means what? That means, actually, for, let me see, for A and B at least, you press calculator and answer it out. Right? But the question asks for an algebraic approach. That means you've got to show your working. It means, yeah, not, of course, this one cannot use graph, but what we are saying here is you have to show your working by hand. Alright? Not by GC. Okay? Not by GC. So, now we have to, and we list out the terms. From A, what we can see is we list out the terms, and then you realize that this actually follows a very nice pattern. It's actually a AP, and your last term is 401. Alright? So the first term, A is 11. Correct? Common difference quite easy is 5. No, sorry, 6. N is, N by observation, you know 66 minus 1 plus 1, therefore it's 66. So far so good? Yep. Alright, therefore you have to apply the formula. This step is super important now. This is 66 over 2. Yep. Then what? You either do this, you can put 11 plus 401, that's no problem. Yeah, or you use the other formula, that's no problem. Alright, 11. Alright, you will. Any problems? All okay? Yep. Yes. Sorry, say again? No, it doesn't have to be. Yeah, no, it doesn't have to be. Yeah. Okay, sorry, actually, sorry, I think, okay, yeah, you can use, this formula is A plus UN, right? This is your formula A plus UN. Alternatively, sorry, actually, this, okay, maybe, what I meant was this, sorry. You could have used Sn equals to 2A plus 65 times 6, or 66 over 2, 11 plus 401. Sorry, because this box is like that. This one. Oh, sorry, I swapped it around just now. This is 2A plus n minus 1b. This is first term plus last term, A plus UN. Oh, Can either way the answer actually quite easy lah. Oh, can? Good. This formula again I stress as n equals to n over 2 a plus u n. This applies for all AP. That means this one the d need not be 1 or d need not be 1. Actually it can be easily shown. Correct? It can be easily shown. Okay, next. Part B. Again, you observe, you list out by listing out the terms. You can observe that is an AP. How is it method? You see 7 minus 3r. In fact, without writing this one, you can quite easily tell that the d is negative. The d common difference is negative. This one, the common difference must be 6. Just by looking at this expression. You can tell? You can tell just by looking at it. Of course, you list out, you will know lah. But you list more, you realize it must be like that. If it's a linear expression, linear expression in terms of I, of course. Linear expression in I, surely the common difference is 6. This one, common difference surely is negative. Hold on, saying right? But never mind, we can always observe and then say that n is 51, and then we can easily do that. Alright? Any problems? This is using first term plus last term, where this is first term. Maybe I don't use this one. Sorry. Plus last term. Alright, n over 2 first term plus last term. Right. Okay, next. C. C now, you must be very clear. This is I, then you have a K here. Right? If you are quick enough, you can also do it by observation. Since K is a constant here, it is an AP with common difference 2K. Does it make sense for all of us? Common difference is 2K. Yes, sub in. Never mind, if you want to sub in, you can also try. Alright, if you want to be super clear, you sub in I equals to 0, you get -5. I equals to 1, you get 2k minus 5. I equals to 2, you get 4k minus 5, Correct? Yeah? And so on and so forth. Okay? So, this is an AP with number of terms equals to what? 40 minus 0 plus 1. 41. Therefore, sum to 41 terms is this. Alright, I use UN first term, which is -5 plus 2k times 40 minus 5. Correct, this is first term. This is last term. Alright, okay. Any questions? Am I going too fast? All okay? Questions? All good? Okay, excellent. There's a box here to say that you must obviously observe that the series is arithmetic. That means you add that all the terms follow an AP before using the formula. A and B can be verified using a GC. In fact, you don't even need a GC to verify. Like I say, as long as you have this kind of, let's say R equals to 1 to 10, whatever, it doesn't really matter what is this, something and something. As long as the summation is a 3R plus 7, surely it is. As long as this is linear. Right? It's a linear expression, we are good. Follow what I'm saying? Makes sense, right? Makes sense, so the linear is good. But what if it's quadratic? Of course, you will learn later on. What if it's cubic? Of course, you will learn later on. But actually, like I said, if it's quadratic cubic, you can always use GC. Okay? Alright? This one I've done before, so I don't want to go through, right? Can I? Right, I've done before, so it's okay. Good. Example 8. Okay. Find the sum of the arithmetic progression. Every third term is removed. Remove, Find the sum of the remaining series. sum of the remaining terms. Okay, let's try and do this. Alright, let's try and do this. First, let us find out how many terms are there. Correct? Because you count 1, 4, 7, 10, 13, 16 to 1000. Actually, not so easy to count. And what you may make mistake. You follow what I'm saying? You may make mistakes. So let's be very safe. Let's say UN is 1000. Then 1, which is the first term. 1 is the first term. 1 is the first term. Plus n minus 1. Can quite easily observe this is plus 3 d equals to 1000. Now let's be very clear. Don't want to make mistakes. So you make mistake, I'm everything wrong. That's the same. Or n is 54. So that's 334 terms. Now you want to remove the third term, every third term. And actually quite easily observe. If you see third term, this follows another arithmetic progression. Right? It's quite obvious. Right? The common difference is now 9. Okay? But you want to take this out. That means your resulting series is this. You actually want 1 plus 4 plus 10 plus 13 plus da 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 da. Correct? This has no pattern. This is not AP. But all you can do is to take the first sum minus this sum. You will get the sum of the A for this. Follow on? What's your name? Jerome. Where are your notes? Okay. Ken? You need to go and wash your face? No, you sure? Okay. So therefore, first we find out the sum of this. This AP means 1 plus 4 plus 7. So that means this is 334 over 2. First term plus last term. Get this. Now every third term follows another AP with first term 7. Common difference 9. Yep. So but then what is the last term? How many terms are there? Actually, you are also not very sure. How many terms are there? Where do you stop? Because we moved the term up. Alright? If you want to be super sure, what we can do is this. Let's try and form inequality. That means this. You are saying that the Vn, the nth term of the new AP, correct, equals to 7 plus n minus 1, 9. Because this is the first term, this is the common difference 9. Correct? You want this, at least you want this to be smaller or equals to 1000. Correct? Then you find the n such that you want to find the largest n such that it's smaller than 1000. Do you follow what I'm saying? You want to find the largest n. So, from here, this one, by solving this inequality, you get n to be smaller or equals to 111.3. That means what we are saying is this. You start n equals to 2, 3, 4, 5, 6, always less than 1000. But you start sticking 111, you'll still be less than 1000. The moment you hit 112, the moment 12 term, 112 term will be greater than 1000, which is not like mine. So actually, with this new AP, you have 111 terms. Very clearly. We're being very safe here, because some of us are able to identify well and good. You can put 1, 1, 1, 1, fine, you can answer correct, good. Answer wrong, no matter marks. Follow? Okay? Alright? So actually you are going to remove 111 terms. Alright? Remove 111 terms. Therefore this new AP will be 111 over 2. 2a, 2 times 7, plus n minus 1, which is 110, times 9. Yes. Say again, point 3. Sorry? Can. Why? As in, actually, it is what? And one third, right? One more and one third, right? Yeah. Yeah. Never mind. Because we know n is, because we know n is an integer. See? In the middle. So, why not 1 from 3? Then how do I represent? Usually we won't put like that. Okay, we usually, I know what you mean. Like that. But usually, even if you want to signify at times, we won't even put dot like that. We must better put bracket. Can. So, yeah. Okay. So therefore, you take you minus the 2 and we're done. Question? Question? Yes. Of course. Yes, you can. Of course.
Why does that bracket 7 is the same, right? It means times.
Yeah, it means times, yes. 2, yeah, same. Means the same thing. This 2 times 7 Oh. Change. Oh, okay whatever. Doesn't matter. 2 times 7 and 2 bracket 7 is the same thing, right? Okay? Is that right? Okay, example 9. Okay, AP has first term A, common difference 10. The sum of the first n terms is 10,000. Express A in terms of n and show the nth term of the progression is this. Never mind, we do one thing at a time. We do this at a time. Alright, express A in terms of n, making use of the fact that the nth term, the sum of n terms, this one, is 10,000. Alright, sum to n terms is 10,000. So which means that it is n over 2, 2a plus 10n minus 1 equals to 10,000. Okay? Alright, make use of the fact that your sum to n terms formula is n over 2, 2a plus n minus 1 d is 10. Okay? The rest is just manipulation. You express A in terms of n. Right. Question? All good? Yeah. Sorry, say last term. What's the last term? Sorry? Last term is not n. You're making use of this one, right? You want to say Sn equals to n over 2 a plus un, right? Yeah, but this one is, what's this? This is also a plus n minus 1 d, which is 10. When you substitute in, you will get that also. You follow what I'm saying? This is last term and this is last term. Not n, this is n term. Question? Okay, good. Okay, then, question. Can I? Next. Now you want to show that the nth term is actually this. Now, I'm making use of, I know there's no copying, but better make sure you know what you're doing. I'm making use of the fact that you are making un equals to a plus n minus 1d. Correct? And what is A? A is this. Correct? So therefore, I substitute the whole A into this. A plus n minus 1. Correct? Because they want us to show the n terms. So after this, the rest I want to go through. Follow this manipulation. given the nth term is less than 500, show the inequality. Wow, all printed for you. No need to copy, so good. Okay, never mind. Un is less than 500. Therefore, you make use of this. This is actually should have a word shown, because they want us to show, right? So we have shown it. That since Un is less than 500, you solve this inequality like that. So now you make use of what you learned in the previous chapter, inequalities. Okay? What you do, you factorize and you make that into a common denominator, you get this. Now, actually, right from the start, you could have multiplied both sides by n. Why? N must be positive, because n is the number of terms. Right? N must be positive. In fact, once you reach here, you can even you get this as well. You will use this to justify. Since n is positive, this. Right? Then you show that it's an inequality. Yeah? Hence, find the largest possible value of n. Yeah, this one is last chapter's work. Can? In fact, this is O-level work, solving quadratic inequality. Can? Oh, we're done. Yes. Must you write? What do you think? What do you think? Must we write since n is more than 0? What? You don't see the point. Can you elaborate? Otherwise, how? Okay, wait. My question to you is, if n is not more than 0, how would you solve it? The question is this, you are, your name? Xiongling. Xionglin's question is, must we write this? Yes. Then my question to him is, if n is not positive, how would you solve it? You have to do, no. Okay, very good, very good. Let's do this. If n is, then you don't know, you don't know n is positive or not, how would you solve it? How would you solve this? That means you don't know whether n is positive or negative, how would you solve it? Test point, very good, you do test point. What are the test points? You have 87.04, you have 73.96, correct? It's 0. Then after that, test point. Correct? Test point, you have plus. Minus, plus. Then how do you solve it? Then you say that you want negative, right? So it here. Right? Right? And then you just follow. Don't follow. And you see that here. That's how you solve it. You follow what I'm saying? Now, then you get what I'm saying? So you need to justify that since this is always positive, it doesn't affect the sign of the whole fraction. Correct? Then you actually solving this logic. Therefore, it's a must to justify this. Must. Do you follow? All okay? Good? Can? Excellent. Question 10. Example 10, sorry. A student saves $10 on 1st January 2009. On the first day of each subsequent month, she saves $3 more than the previous month. So that she saves $13 on 1st Feb, $16 and so on. On what day will she first save $2,000 in total? Now, can I just say this, okay? This is probably the easiest question you will, A-level question on AB will ever find. Cannot be so easy lah. Really, seriously, it's really too easy but it's an A-level question I don't think this, 2008. You will take your exam 2017. That's 9 years after this. So I tell you, A-level standard has increased significantly over these past 9 years. Cannot be so easy. Seriously, cannot be so easy. But never mind, but the approach should be similar. The approach should be similar. The idea is to list out the terms. Right? To list out the terms and say 10 plus 3, 10 plus 2, 10 plus 3, etc., etc. To observe that first is an AP. Alright? Yes. On what date will she first have saved $2,000 in total? Okay, in total, let's be very clear, okay? So, if first month you save $10, second month you save $13, and on and on. So, at the end of n months, you will use this idea of n months. First term is 10, that means A is 10, n terms is A plus n minus 1. So what's the good? So you want to get all this together. You write this out. Of course, if you ask me whether it's absolutely necessary to write this out, I won't minus 2 marks. Actually, if you can observe from here, so write this out and see that this is sum to n terms, just give me the formula, I'm fine. I'm fine. That means you give me this next step at least. You must give me this next step equals to n over 2, 2a plus n minus 1, d is 3. Okay. That means if you don't write this and you just put this directly, if you need this, then go ahead and write. Follow? Okay? All good? Alright. You simplify and you realize that this is n over 2, 3n plus 17. Now, look, I want to emphasize this. All of us are F-math students, okay? We cannot make this mistake like what? Yeah, I don't want to say what, but F-math students must have this idea of inequality. You want to say over 2,000. So when you say that you want to say over 2,000, you cannot put equal to 2,000. The next step you ask to solve an inequality. Follow what I'm saying? Must have inequality. Because here, I want to emphasize this inequality. You want to save over 2,000. Because you will have a problem with equal. Can you imagine if you say you equate equal, you want to solve the quadratic equation, in the end, you get full solutions, then you see 33.8. Your dilemma would be round up or round down. I have no idea. Unless you use a bit of common sense. You follow what I'm saying? So to eliminate that kind of uncertainty, definitely I would emphasize on it. Since you are over 2,000, you must have equality. Then you are very clear, you are solving an quadratic inequality, your solution is an inequality. Then you know for sure n must be greater than 33.8, then you must round up. Even if 33.1, you also round up. Follow what I'm saying? If it's 33.1, you also round up. Question? Good. So it is actually 34 months. Okay, can I ask you to do this simple exercise? What day is it? Count. Then we answer. N equals to 1 is January 09. Right, you're right on your own. If you are very sure, right, write in pen. I'm not sure, write in pencil, then we check answer. Okay? No, what I mean is this. Right. Answer. Because the question is very clear. The question didn't ask after how many months. The question asks, what is the day? Right? Correct? Am I right? On what date? 1st March 2011. November. Who said of you say November? Any other answer? October. Okay. Don't even say other people. You think happy for 3 minutes to 2 minutes. Then we check. Don't even think happy you mean? Wait, I want to answer already. You wrote down already? I see. So, yeah, you don't answer. You don't discuss. So, all the way. Really think about how we did it. Because this problem will come again. This counting problem will come. I have a way to do it, that's my way. I don't know whether it will help you. It's best if you discover it on your own. It really is best if you discover it. My clue to you is this. My clue to you is, let's be very clear, what does n equals 1 mean? If you're very clear what n equals 1 mean, then n equals to 34, what does it mean? You will be super clear. Before? Yeah? Okay. Still no agreement and Taylor? No agreement. October. Okay. So I don't explain, right? Can you all recall? Huh? No, I'm not even explain because you have your own. I'm sure you have your own way of convincing yourself.
Just say
Just say Just say Look, the answer is 34. First, you must be very clear what does n equals to 1 mean. Correct? N equals to 1 means that is January 2000. Correct? January 2000. Now you want to know what does 34 mean. I will do it like that. I will say, okay, actually after 1 year, which is n equals 30, it will be 1st January 2010. Correct? Then multiples, so you count. Of course, if this is 102, you don't go and count add 12 and 12, you go and find some way to see how many 12s are there, right? So therefore, 25 is 1st January 2021. Then you see how many months have passed. Then you can count it's October. Then 9 months have passed. Correct? Therefore, it's October. Correct? Somebody did it and also quite good is this. If take 34 divide by 12, you actually get 2 years, 10 months. Correct? 2 years, 10 months. Correct? So if 2 years, 10 months, 2 years, of course, you get the same month you get. After 2 years, you get 25. Oh, sorry, you get more like. See, this is 2 years, 10 months. If n equals to 1 is January, you get 10 months, means must be October. Correct or not? So that's how we see it as well. But I prefer, you know what I'm saying? If 1 is January, then 10 months must be October. What I'm saying? Right? But you must count years. Some had confusion within 2011, 2012. Or must be very clear. After 2 years, 2011, then another 10 months again. You can see in 2011. Or, actually, what I say is not important. Really, really. What I say is not important. It's best that you discover on your own, go through the thing process, and you get it. What I say is really super. It's really not important at all. Okay?